for tuning in to Planetterrian Daily, episode 103. Today is June 27th, 2026. Let's get into today's research and health developments. A solid-state material converts visible sunlight into higher energy ultraviolet light for potential purification and manufacturing uses. Scientists at the Max Planck Institute for the Science of Light developed a technique to interrogate molecules on surfaces with spectroscopic precision. Their work, published in Science, reaches the ultimate quantum limit for the first time. The method reduces surface interference that previously masked molecular signals. It opens routes to study molecule surface interactions at the level of individual quantum states. The team expects applications in molecular quantum technologies and surface catalysis research. Now, shifting to a very different area of research, researchers at Penn State and NIST built miniature glass cells containing precisely controlled atoms for sensing applications. The design improves stability and reduces size compared with traditional vacuum-based systems. Potential uses include more accurate navigation and wireless communication devices. The atoms remain isolated from external interference inside the sealed glass structure. The team is now scaling fabrication methods for broader deployment. On a different note, researchers created a solid-state compound that absorbs visible wavelengths and re-emits them at shorter ultraviolet wavelengths. The process overcomes previous barriers that limited efficiency of such upconversion. Potential uses include sunlight-driven air purification and chemical synthesis without external power. The material operates at ambient conditions using only natural illumination. The team is optimizing stability for longer-term outdoor deployment. This opens a route to sunlight-powered chemical processes that previously required artificial ultraviolet sources and could support distributed air purification systems where electricity is limited. Next up, a gene editing study clarified how reactive oxygen species molecules function in normal plant development. Researchers altered specific reactive oxygen species-producing enzymes and observed disrupted cell division planes and altered organ shapes. The work demonstrates that localized reactive oxygen species gradients help establish correct tissue architecture. Experiments were performed in model plant systems with targeted knockouts. The group will next test whether similar mechanisms operate in crop species under field conditions. Shifting focus, researchers at King Abdullah University of Science and Technology led a global assessment of marine responses during the first year global temperatures exceeded 1.5 degrees Celsius above pre-industrial levels. The study documented shifts in species distributions and phenology persisting across seasons. Data covered multiple ocean basins and trophic levels. The results show that even temporary temperature spikes can produce extended biological effects. Future work will examine recovery trajectories once temperatures return below the threshold. On another front, a new study tracked how feral goldfish alter water clarity, food webs, and native fish populations. The fish increase turbidity and compete for resources, sometimes triggering shifts in community composition. Experiments and field observations documented these effects across multiple water bodies. The work shows that even a familiar pet species can act as a significant ecological disruptor once established. Management efforts will need to address both prevention and removal strategies. Moving to a different scale, researchers from Animal Ecology conducted a bioblitz across the Uppsala Botanical Garden and recorded the small blue butterfly in one of its meadows. The species is classified as vulnerable and appears abundant in that specific habitat patch. The survey aimed to document insect diversity within the urban botanical setting. The find adds a data point on how managed green spaces can support threatened pollinators. Follow-up monitoring will track whether the meadow conditions sustain the local population over multiple seasons. Now, turning to ancient records, Flinders University researchers partnered with the River Murray and Mallee Aboriginal Corporation to study the Sugarloaf Hill Quarry. Dating of chert and silkreed artifacts establishes continuous extraction activity over 7 millennia. The work represents the first detailed investigation of an Aboriginal quarry in the Riverland region. Artifacts indicate systematic selection and processing of raw materials for tools. Further excavation will map the full extent of the extraction area and associated activity zones. In paleontology news, a study in Earth Science Reviews examined bioerosion traces on fossils from the Lojuico site in Cuenca, Spain. Perforations appear in both bones and dermal osteoderms of titanosaurs from the late Cretaceous. The structures provide evidence of insect activity after death and inform understanding of ancient ecosystems. This marks the first report of such traces in titanosaur armor at the locality. Researchers will compare the patterns with modern beetle boring behavior to refine taphonomic models. Here's something most people get wrong about kitchen fats. Butter contains naturally occurring fats that produce distinct browning and flakiness, while margarine uses modified plant oils engineered for uniformity and shelf life. The structural differences affect how each fat melts, emulsifies, and interacts with dough or batter. Nutrition labels may list similar total fat content, yet the molecular arrangement drives functional outcomes in recipes. Right now, as fats interact with proteins and sugars during baking, butter's mix of saturated and unsaturated triglycerides creates distinct flaky layers, while margarine's hydrogenated or interesterified oils produce more uniform texture and longer shelf stability. A single gram of fat can contain thousands of different triglyceride species, yet the average chain length and saturation level shift the entire physical behavior. The practical takeaway is to select the fat according to the outcome you need. In plant physiology, scientists at the USDA Agricultural Research Service tested modern rootstocks during 6 weeks of progressive drought stress. Different rootstocks maintained different levels of vigor and water use efficiency. The trial recorded physiological responses, including stomatal conductance and biomass retention. Results will guide rootstock selection as weather patterns become less predictable. Turning to controlled environments, Purdue University researchers grew lettuce under sole source lighting with added far red wavelengths and higher carbon dioxide. The combination produced significantly more biomass than either treatment alone. The study supplies practical data for indoor farming operators adjusting light recipes. Measurements focused on early vegetative growth stages. Operators can now test similar spectral and atmospheric adjustments in commercial settings. On atmospheric transport, new measurements published in Geophysical Research Letters show that the mountain range does not fully block air pollution from South Asia. Researchers track pollutants reaching remote sites on the Tibetan Plateau. The findings indicate that prevailing winds carry fine particles and gases over the barrier during certain seasons. This challenges earlier assumptions about the Himalayas acting as a complete atmospheric divide. Continued monitoring will quantify seasonal transport rates and chemical transformation during transit. In space weather observations during the May 2024 geomagnetic event revealed that the majority of ions contributing to the ring current originated from the planet itself. The data came from instruments aboard multiple spacecraft inside the magnetosphere. This source partitioning differs from some earlier storm analyses that emphasize solar wind input. The finding refines models of how Earth's atmosphere supplies particles during extreme space weather. Additional events will be examined to determine how common this pattern is. A study from the Department of Psychology at Lingnan University examined how frontline staff navigate hierarchical workplaces. Employees who actively seek learning opportunities and demonstrate stronger emotional intelligence showed higher job engagement and output. The research focused on upward mobility challenges created by large organizational gaps. Results indicate that both proactive behavior and emotional skills together amplify performance more than either factor alone. The department plans further work on how these traits interact across different team structures. Before we go, keep an eye on further measurements of seasonal pollutant transport across the Himalayas and recovery patterns in marine ecosystems after temperature spikes. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Modern investing techniques, modern strategies for Canadian and U.S. investors. Find every show free at neuronetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.